Hello class, Miss Emami here. I hope you are all fine and doing well. So today we are going to continue with our new unit, TrigFunctions. Yesterday I asked you to watch a video from University of Waterloo about how we create the graphs for sine and cosine functions. And today we are going to go and look back at those graphs and talk about some of their features, which is important for us when we are going to graph what we call sinusoidal functions, which are sine and cosine functions. We are going to start by looking the graph of sine theta. As you can see, the graph of a sine theta starts here from 0, 0, and it sort of goes all the way at 90 degree. It reaches the maximum of 1, then comes back here at 180. It is at the x-axis. Then at 270 it's going to -1, and at 360 it goes back to the axis. Now typically when we want to graph a sine function, although when this was created, the 30-degree angle and the 60-degree angle, 120, 150, we looked at all the values of these points. When you want to generate the sine and cosine function, these are the 5 key points which will actually help us to pattern of the sine functions. Now we are also going to look at the cosine function, and this one starts from 1, and then the next key point is at 90. It is at the x-axis. Then at 180 at -1, back at 0, and then at 360 it gets back to 1. So again, these are the 5 key points that we will keep in mind in order to remember the pattern of cosine function and graph it. Now we are going to talk about some of the features of sine and cosine functions. Now, as you remember, the way that the sine and cosine functions were created was that we had what we call the unit circle, and we started traveling around this circle. So 0 degree, 30 degree, 60 degree, here halfway 45 degree, 90 degree, and so on and so forth. So the way we actually created this sine and cosine function was that we started from 0 degree, we measured what is the sine of 0, then the sine of 30, then the sine of 45, sine of 60, sine of 90, and all the way around until we got to 360, and we connected the points and the graph was created. Now if you think about it, when we get back here to 360, if we continue another rotation, because we will have the same RAA, we will get the same measures for our sine. So exactly the same pattern will happen. And then if we do it again beyond 720, again the same pattern will happen. Now, if we go for a negative rotation angle, meaning that if we go clockwise, again we will hit exactly the same points on terminal arm, and we will get the same value. That's why these functions, sine and cosine functions, are called periodic functions, meaning that they return to the same value at regular interval. So as we go beyond 360, the same values will be encountered for our sine and cosine value, and the same thing is if we have a negative rotation. So both sine and cosine functions are considered periodic functions. So now we are going to look at their graphs again. So this is what we call a cycle of sine function that you saw being generated in yesterday's email. But if we go from 360 to 720, again the same pattern is going to happen. And then if we go to negative angles, like we rotate clockwise, again the same pattern will happen. And this will continue both ways to infinity. Now, this was our cosine pattern that we started from 1 to the axis, to the minimum -1 axis and positive. Now, if we continue with this beyond 360 and do one full rotation, again exactly the same pattern is going to repeat. And again the same pattern is going to repeat. Now I am going to introduce two definitions here, two vocabulary here. The first one is cycle. A cycle of a graph is the smallest complete repeating unit. Think about the idea of copy and pasting. What is the smallest unit you can get from the graph and keep pasting it, and you will get this periodic graph. And then what is a period? We look at what is the length of this one complete cycle, and that is called the period of the graph. So now we are going to do that for both sine and cosine function. Now, if you look here, this is going to be our cycle, because this is the smallest repeating unit. So this is considered one cycle. So this is one cycle. So it actually looks like this. Now the period is the length of the cycle. So from here is 0 to 360. So the period is 360 degrees, which is the unit on our x-axis. Now we look at the cosine function. Again, the smallest repeating unit that, as you can say, we can copy and paste is this one. So this is actually considered one cycle. So if this is our x-axis, it looks like this. And then the period is the length of this cycle, which is 360 degrees. So for both sine and cosine, the period is 360 degrees. Now, this is not necessarily the period and cycle is not only for sine and cosine function. You can have them for any periodic function. So let's do an example here. For example, let's look at this one. We can still talk about period and cycle for this one. We look at the graph and we try to figure out what is the smallest repeating unit. The smallest repeating unit is going to be this. If you think about it, that's the smallest that you can copy and paste, and you create the same periodic shape. Now we have to figure out what is the length of this. So this is 1 and 2. So the period for this is 2. And we don't know what is the unit on the x, so simply we write the period is 2. So any periodic function, when you find the smallest repeating unit, that's going to be your cycle, and then the length of that unit is going to give you like 1, 2. It's going to give you the period. Now we are going to introduce 2 more features about periodic functions. And those are called amplitude and axis of curve. Okay. So axis of curve is a horizontal line halfway between max and minimum value of a function. Now, it is a horizontal line so that means when you want to write the equation of a horizontal line, you write it in the forms of y equals a number, okay? So horizontal line, that's the equation of a horizontal line. Now, in order to find this b, to be able to write the equation, you have to add max plus min value and divide it by 2. This is one of the very important formulas I'm going to say memorize. Now, amplitude is the vertical distance from axis of curve to max or min. Now, you always have to represent it as a positive number. This is very important, so I am going to actually highlight this. Now, amplitude is a value. In order to find the amplitude for your function, you find the difference between the max and min value and then divide that by 2. So that is the second important formula for memorizing. Now we are going to look back into our sine and cosine function and find the axis of curve as well as the amplitude. Now, y equals sine theta. The max equals 1. That's as high as it goes. And the min here is -1. axis of curve, if you remember, I'm going to write the formulas again here. Axis of curve, y equals max plus min divided by 2. So y equals maximum is 1, minimum is -1 divided by 2. So y equals 0, which is the same thing as x-axis. So this is the axis of curve, which is, I'm gonna draw it here in dotted line. So this is your axis of curve. Now the amplitude, I'm going to write the formula here. The formula for amplitude was max minus min divided by 2. So the amplitude is 1 minus -1 over 2, which gives us the amplitude equals 1 minus 1 is 2, 2 divided by 2 is 1, So if you think about it, this is your amplitude. The definition says the difference between the max to the axis of curve or the distance, or this is your amplitude. The vertical distance between axis of curve and mean, or axis of curve and max. And these are the formulas we are going to use. Now for cosine theta, we have the same max and mean values. Max is 1, min is -1. So we will have exactly the same axis of curve. So y equals 1 plus -1 over 2. So the axis of curve is the line y equals 0, which is x-axis. So I'm going to graph it with a dotted line. And your amplitude is 1. So for our basic sine and cosine values, we know that axis of curve is y equals 0, amplitude is 1, and the period is 360 degrees. Now, what we are going to do as practice is I am going to show you some sinusoidal functions, so either sine and cosine, where there have been some transformations happening. We don't know what kind of transformation, but we want to find out what is the amplitude, axis of curve, and period for these functions. Okay, now what you start with in these kinds of questions is you always, in order to find the amplitude and axis of curve, you need to know what is your max and min. So I start by finding those. So max, I look here, the maximum value is at 4. And the minimum value here is at -2. So maximum, and this is the minimum. Now we know that axis of curve y equals max plus min divided by 2. So max plus min divided by 2, y equals 4 plus negative 2 divided by 2. So the axis of curve is y equals 2 over 2 is 1. So this is axis of curve. I am going to actually draw the axis of curve with dotted line because it will help me later to figure out my period. So you always label it, okay? You draw it with dotted line and you label it, okay? Now I need to find the amplitude, so I'm going to do here. Amplitude is max minus min divided by 2. So amp is 4 minus negative 2 over 2. So the amplitude is 4 minus negative 2 is 6 over 2 is 3. And as you can see here, you can also visually see that if this is the axis of curve, this is the amplitude. Now you have to find the period, so you are going to look at this function with respect to the axis of curve and see what is the smallest repeating unit, which is of course this one. And then we look at the length of this. We look at length of this, and this will be your period. It is 180. So I'm going to write here, period is 180. So the important features of any sine or cosine or any periodic function, the max and the min. Given max and min, using the formulas, you can find the axis of curve, you can find the amplitude, and then after you draw your axis of curve, you can see what is your smallest repeating unit, and looking at that, the length of that unit is going to give you the period. So this is not the basic sine function, but this is a sine function gone through some transformations, and that is what we are going to learn in the next lessons to come, that how a function's graph is going to change all its features when we do different transformations to the basic function. Now let's do one more of these practices. So this is another sinusoidal function, and we want to find the axis of curve, period, and amplitude. The first step again is to first figure out what is the max and the min. So I'm going to write here, maximum is actually -1, minimum is -5. So I start with axis of curve. Axis of curve is max -1 plus min -5 over 2. So y equals -6 over 2 is -3. This is the axis of curve. And as I said before, as soon as you find the axis of curve, I want you to actually draw it using dotted lines and label it. Y equals -3. Now the next thing we want to find is the amplitude. Amplitude is max minus min. So -1 minus -5/2. So the amplitude will be 4/2, which is 2. As you can see, it is right. The distance between the max to the axis of curve or min to the axis of curve is actually 2 units. Now the last thing we want to find is we want to look at this and figure out what is the smallest repeating cycle. So if you look here, this is the smallest that we can repeat this and we get our periodic function. Now we need to look at the length of this. It is 720. So this is the period. So the period is 720 degrees. Now we are going to do another kind of example here, where some features are given to us and we are trying to draw one cycle. Okay, so we know what's the amplitude, we know what is axis of curve, and we know what is the period here. Okay, so first I am going to put my x and y. Y and x. Now axis of curve is at y equals 3. So 1, 2, 3, 4, 5, 6. So the first thing is always to start with axis of curve. That's always your first attempt, should be the axis of curve in dotted lines. So this is the axis of curve, y equals 3. Now we know that the amplitude is 2, means that the maximum is 2 above axis of curve and the minimum is 2 below. So if you think about it, your max will be whatever is your axis of curve plus the amplitude, which is 5. So it's going to be axis of curve, and that is amplitude. And in order to find the min, you have to go 2 below the axis of curve. So that means your max will be 5, your min will be 1. And if you remember, the period is 360. So I'm going to put here 360. And the pattern for our sine, if you remember, was it always started from axis of curve, went all the way to the max, came back to axis of curve, came back to min, and then back to axis of curve. So 360. We talked about 5 key points. The pattern was axis of curve max, which is 5, back to axis of curve, go to minimum, and then go to axis of curve. And the whole period was 360. Now you know that this thing will continue forever. You were not asked to do it, but you know that forever this pattern is going to continue. Now, one more example here. This time we are interested in a cosine function. Amplitude is 4, axis of curve is -1. So I said before, we always start with axis of curve. So y, x, the axis of curve is at -1. So I'm going to start by drawing that one. Y equals -1. Now, the amplitude is 4, so that means the maximum will be 4 above this and the minimum 4 below this. So your max will be -1 plus 4, which means all the way to 3, and the minimum will be -1 minus 4, which is 5. So this is going to be our max. And our min is going to be -2, -3, -4 here, -5. If you remember, the pattern for a cosine started from the maximum, going all the way to axis of curve, then goes to minimum, comes back to axis of curve, and then goes back to our maximum. So max, axis of curve, min, axis of curve, and max, and of course this whole thing is going to continue. Okay, now the period is 720, so this one full cycle will go all the way to 720 degrees. There are some questions from the homework that I want you to do. It is very important to do these questions because these are our basic sine and cosine functions, and you need to know them very well in order for us to be able to continue with this unit. Stay safe until we have another lesson. Goodbye.